Come on, Woody, enough of this messing around. It's time to put the A in STEAM.
That's the stuff I've just been talking about, Dean. You mean art?
No, I mean airborne.
Oh, okay.
It's time to lift off. Good luck, teams.
Welcome to the first robotics competition and the 2017 game, First STEAMWORKS! 2 adventurer clubs, alliances of 3 teams each, prepare for a long-distance airship race by collecting fuel to build steam pressure, installing gears to engage rotors, and climbing aboard for liftoff. The airship best prepared for flight when the launch timer reaches 0 wins. Matches begin with robots touching their Alliance Station wall. Teams may preload up to 10 fuel elements and 1 gear on each robot. Fuel is available in hoppers placed around the perimeter of the field. Additional fuel and gears are available at the Alliance loading station. During the first 15 seconds of the match, the robots are autonomous. They work to reach their baseline, score fuel in the boiler, or deliver gears to the airship. During the following 2-minute and 15-second teleoperated period, human drivers remotely control their robots. They continue to gather fuel from the field and the hoppers to score in the boilers. They also collect and deliver more gears. Human players located behind the Alliance Station wall deliver gears and recycled fuel to robots through the loading stations. Steam pressure builds as fuel is added to the boilers. The high boiler produces more steam per unit of fuel than the low boiler. The more fuel scored in the boiler, the higher the steam pressure climbs. Alliances earn points for the amount of steam pressure built, and pressure over a certain level earns an additional bonus. Each airship has 4 rotors, with some gears missing. Oh dear. Gears delivered to the airship lifts are retrieved by the airship pilots, who then place them in the gear train to engage and spin up the rotors. Each rotor requires an increasing number of gears to become engaged. Points are awarded for each airship rotor turning by the end of the match. Airships spinning all 4 rotors also earn an additional bonus. Towards the end of each match, pilots deploy ropes for their robots to climb aboard. Alliances earn points for each robot secured aboard the airship by the end of the match. Be prepared. It takes time for the boilers to process fuel for the airships. Fuel put in the boiler near the very end of the match may not get processed before the airship takes off. The alliance with the highest score at the end of the match earns the win. Ready your robot, fly your banner, and prepare to take flight with this year's first robotics competition, First STEAMWORKS! Ha ha!
Hi, I'm Jasmine, and this is Derek. We're here to show you the boiler. It converts fuel to steam and then back into usable fuel. Don't ask, it's magical. Each alliance has a boiler at the end of their wall. Just in front of the boiler is the key. This area is marked with alliance color tape that is parallel to the face of the boiler. The tape is part of the key, and the far edge is 4'4" from the face of the boiler.
Each boiler has a high goal and a low goal. The low goal is a rectangular opening in the front face of the boiler. It's 8 3/4 inches tall, 25 inches wide, and the bottom edge is 18 inches from the floor. The high goal is a round, horizontal, 21.5 inch diameter opening that's 9 feet from the floor and set back from the face of the boiler, 17 3/4 inches. The geometry of this can be approximated using 6 totes and a recycling container from 2015's game, Recycle Rush.
Recycle.
There's a vision target just below the high goal. It's made of 2 pieces of retroreflective tape that wrap around the tube. The top of the higher piece of tape runs along the seam where the stack meets the funnel. It's 4 inches thick. A 2-inch ring is 4 inches below it. The back of the boiler is surrounded by nets that extend about 10 feet above the floor. These nets are intended to keep missed shots in the field and not designed to behave consistently, so don't count on them as reliable backboards. You'll see that the manual specifies that fuel is scored as it's counted, not as it's put in the goal. For that reason, it's important to understand the rate at which the boiler can process the fuel. Our testing has shown a range of 4 to 5 fuel per second for each of the goals in the boiler, so 8 to 10 total fuel per second.
We also want to make sure you're aware that the goals have capacity limits. If you exceed capacity, the excess fuel will overflow out of the goal and onto the floor. Finally, any fuel that's not counted when the timer reaches 0 doesn't count for that period. So fuel that's put in a goal with 1 second left in auto, but not counted until 2 seconds later, will be counted as a teleop score. Additionally, fuel that's put in a goal with 1 second left in teleop, but not actually counted by the time the match ends, won't build additional pressure.
Full steam ahead. Hi, I'm JB, and this is Chuck. We're going to show you the hoppers. Each hopper is a pair of containers that sit just outside the guardrail. Hoppers are full of fuel, 100 fuel per hopper, split evenly between each container. Hoppers are staged around the field, 2 on the scoring table side and 3 on the opposite side.
To dump the fuel from the hopper, the robot pushes against this panel. It's 1 foot 10 inches wide by 1 foot 3 inches tall. As it's moved, it lowers the bottom of the container, and fuel is dumped from a height of about 2 feet. Containers are 2 feet 6 inches apart, so fuel dumps in 2 separate locations.
Hi, I'm Amanda, and this is Malcolm. We're going to show you the loading station from the robot side. If you want to see it from the human player side, check out Jamie and JB's video, Loading Lanes. Your Alliance has 3 loading stations where you can collect game pieces from your human players. A single station is part of your Alliance wall, and a double station is part of your opponent's Alliance wall, located in the corner on the scoring table side.
Each loading zone has an opening through which game pieces fall. The opening is 7.5 inches tall, 2 feet wide, and the bottom edge is 2 feet 1 inch from the floor. The space in front of the loading station is the retrieval zone, because that's the zone where the robots retrieve the game pieces. It's marked by Alliance colored tape that is parallel to the face of the loading station. The tape is a part of the zone. The far edge is 3 feet 4 inches from the face of the station.
Hi, I'm Amanda, and this is Danny. Jasmine and Alex cover the ropes from the pilot's perspective in the airship. But we're here to show you the ropes from installation and robot perspectives. Each rope is suspended from a davit. They're equally spaced around the airship. One davit extends from the center of the railing closest and parallel to the Alliance wall. The other 2 are 120 degrees away.
If you choose to bring your own rope, make sure you read the game manual carefully about what you can and can't do. You'll want to make sure your retention knot is solid so the rope remains installed while your robot climbs it. Regardless of if you're using a field rope or your own rope, all ropes pass through the center of the touchpad and must be coiled and stowed before the match starts.
The field knows if a robot's ready for takeoff if it's triggered the touchpad. The piece of the touchpad which the robot interacts with is a horizontal polycarbonate plate that's 4 feet 10 inches off the floor. The plate must be pressed for at least 1 continuous second and while the match timer hits 0. It takes about 3 pounds of force to move the plate and has to be displaced by at least a ½ inch in order to trigger one of the sensors, with an additional 1 inch of travel.
The other important piece of the touchpad is the light because it communicates information. When there's 30 seconds left in the match, the light blinks. Also, if a robot's doing all the right things to actuate any of the sensors, the light will turn on and the associated points will be added to the Alliance's score. We need to be really clear though. Just because the light's on doesn't mean those points are guaranteed. If the robot were to let go of the plate before the end of the match, the light will turn off and the points will disappear from the Alliance's score.
Way to end our video, Danny Downer.
Hi, I'm Jasmine, and this is Alex. We're going to take you on a tour of the airship. As we've said in blogs, manuals, etc., safety is crucial in the first robotics competition, especially this year when humans will be on the field during the match? What?
That's right. For the first time ever, drive team members will be allowed on the field during a match up in the airship. First up, pilots will need to climb aboard. Each airship has a ladder installed on the side facing the center of the field. The ladder will be down during field reset so that pilots can climb aboard. Before the match starts, a member of the field staff will fold the ladder up, securing the pilots until the match is over.
The pilots are protected from the robot action below by polycarbonate walls. There are portholes in the wall next to each lift for retrieving gears, but make sure you never reach outside the portholes. The portholes have another use too. In the case where fuel gets in your airship, we don't want you tripping on it, so use the portholes to clean it out of your way. Check the rules. This is the only way to get fuel out of your airship.
There are specific rules about what you can't touch while you're in the airship. The manual requires that you stay away from rotors, davits, and like Jasmine said, don't reach outside a porthole. Last note on safety. You're probably not surprised to hear that pilots will have to wear safety glasses while in the airship. We strongly encourage all pilots to secure their safety glasses with straps. Also, avoid loose-fitting clothes and tie long hair back.
One of the pilot's jobs is to receive gears. The only way to do this is with a lift. This video covers it from the pilot's perspective. Malcolm and Danny talk about it from a robot's perspective in the lift video. Once a gear is on a peg, a pilot operates the lift by pulling the cord to raise it up to the porthole. The pilot then tilts the carriage to bring the gear inside the airship where it's safe for the pilot to grab. When the pilot lets go of the cord, the peg falls back down to its lowest position. There's one exception where you don't have to use the lift to get a gear, the reserve gear. Once teleop starts, a pilot can grab the gear that's staged on the airship.
Once you have a gear, you'll want to install it. If you're using it for the center rotor, you just have to put it in the slot. A sensor will see it and start it up. To get the other rotors moving, you'll need different numbers of gears. They get installed on axles mounted vertically on the railing. The pilots just need to install each gear on an axle and line it up to make sure the gears mesh.
Once you've completed a gear train, you can start up that rotor. Do this by turning the crank for at least 3 revolutions. If the gears are meshed properly, a sensor will read that the gears are turning, and the FMS will start that rotor. Heads up though, the more gears in a gear train, the harder it is to get them turning.
Another job for the pilots is to deploy the ropes. This is done by opening the hook and loop strap. Finally, all this needs to be done while maneuvering around the steam tank. It's right in the middle of the ship and 2 feet wide, leaving pilots about 2 feet to work with. Lights show the amount of pressure in the steam tank. At 10 pascals, a row turns white. At 20 pascals, the row changes to the Alliance color. At the end of the match, the steam pipe lights will turn green. When the field reset crew lowers the ladder, the pilots can disembark. Up, up, and away!
I'm Malcolm, and this is Danny. Jasmine and Alex cover the lift from the pilot's perspective in the airship video. We're here to show you the lifts from a robot's perspective.
Each airship has 3 lifts. One lift is centered on each edge of the airship that faces towards the Alliance wall. I also want to point out the baseline, which runs just below the center lift. Make sure you read the game manual about getting those auto points. Given the geometry and various ways you could design your robot, placing a gear on the peg doesn't necessarily mean that you've technically reached the baseline. Pegs are relatively stiff springs with a barb on the end, which helps retain the gear. They extend about 11 inches out from the carriage. When the lift is at its lowest position, the top of the spring is about 13 inches from the floor. While the only way to get a gear to a pilot is by using the lift, there's no prescribed way to put a gear on the peg. Once the pilot determines the gear is safely on the peg, they can lift it up and away from the robot. Once they let go, though, the peg drops back down to the floor.
Drivers, use caution when interacting with the peg. It could impale your robot or get stuck in ways that could be debilitating. Or if dropped from the top by a pilot, could cause unanticipated damage. The final feature we want to show you are the barriers between the two lifts. There are two, and they flank the center lift. These are mounted firmly to the ground. The barriers are about 2 feet long and 6 inches tall, and shield the gear placing robots from getting hit from the side.
Hi, I'm Chuck, and this is Matt. We're here to take you on a tour of the Alliance Station, including features that are unique to First STEAMWORKS. The most obvious difference is that the Alliance Station is smaller than in previous years. It is surrounded by the opponent's loading lane, so it's only 22 feet 4 inches wide by 8 foot 9 inches deep. You'll notice that there's a panel called a loading station between two of the player stations. If you're on the Red Alliance, it's between stations 1 and 2. If you're on the Blue Alliance, it's between stations 2 and 3. This is where your human player feeds fuel from your overflow bin back onto the field. You should watch out for any loose fuel on the floor. If this happens, we recommend you put it in your overflow bin or back onto the field via the loading station. JB and Jamie give more information about bins and how to use a loading station in their video, Loading Lanes.
The overflow bin is staged here, next to the boiler. If your opponent's bin overflows or isn't there, scored fuel ends up in your bin. It can be removed to transport fuel over to your loading station. Each player station has a shelf for an operator console. Note the strip of 2-inch wide hook and loop tape, loop side up. Each player station has an Ethernet cable which connects the operator console's computer to the field management system. The e-stop button on the shelf lets you disable your robot if necessary. There's an AC outlet for your operator console with a 2-amp fuse. If you find yourself in the middle player station, watch out for the equipment under the shelf.
Notice the stack lights above each player station. They relay information to the field crew for quick diagnostics. The bottom amber light indicates that your robot has been e-stopped. The top two lights match the Alliance color. If they are off, it's before the match and the robot is linked, but disabled because the match hasn't started yet. If the lights are flashing slowly before the match, once per second, it means that your robot has not yet linked to your driver's station. If your robot loses connectivity with the driver's station during the match, the lights will begin to flash again until connectivity is reestablished. If they are on, the robot is connected and enabled. You only see this state during a match. Each player station has a team sign that displays their team number throughout the match. The official time remaining in the match is displayed on signs hung from the top of each double loading station, which are identified with a white strip of tape. Don't forget to bring your banner to the field with you. Above your team sign is a holder for your standard. Make sure to place it securely so that it doesn't become dislodged during the match.
Above the wall, you'll notice the steam pipe. It starts at the boiler, runs across the top of the wall to the midpoint where it turns towards the airship. The steam pipe has lights that chase through it to indicate that steam is flowing from the boiler to the steam tank. Two more things. The starting line is 2.5 feet away from the Alliance wall. Operators must stay behind it during auto. Visibility will be tricky this year, as large airships obscure parts of the field.
Hi, I'm JB, and this is Jamie. We're here to show you the loading lane. We'll start at the output of the boiler. When a robot puts fuel in the boiler, it's counted and ejected into the bins. Fuel fills this bin first. You'll want to pay attention to this because if your bin is full, the fuel is redirected into your opponent's bin. You can take the fuel from your bin or you can remove the bin completely. There are 2 other bins staged in your loading lane, so if you take the bin away, you'll want to put another bin into its place to keep the fuel from going to your opponent. The front of the bin holder marks the front of your loading lane. You're not allowed to touch anything outside of it. There are moving parts up there, so it's especially important that you stay back.
The bins are plastic, 33 inches long, 17.5 inches wide, and 13 inches deep. And they're pretty light, so even when they're full, they're manageable by most people. There's a double loading station on the opposite corner of the field from the boiler, and this is where you can feed fuel and gears to your robots. Fuel can be dumped or dropped into the chute at a height of 3 feet, 7 3/8 inches, and it will immediately roll out onto the field. The gears are staged here, in front of the starting line in the loading station. They get fed into the chute via this slot. To prevent a robot and human from being in contact with a game piece at the same time, something we fear could lead to injury, you can't be in contact with any inside surface of the chute or any part of a game piece that's inside the chute. So we strongly recommend that you play it safe and keep your hands out of the chute.
With all the motion included on the 2017 playing field, we asked our friend Jay Flores, Global STEM Ambassador at Rockwell Automation, to join us to talk about the components which make all this magic happen.
Let's start with the Alliance stations. Jay, what can you tell us?
Each Alliance station includes a Station Control Cabinet, or SCC, in Player Station 2. There's an armor block input-output module for controlling the LED pendant lights, and it tells us when an e-stop is pushed. The SCC has components to send power and data to the team number signs and acts as the Ethernet interface between the scoring table and the Alliance station.
More details on the software side of the SCC and how it operates with the rest of the field management system can be found in the FMS white paper.
Wow, so that's what the big white box does.
Now let's take a look at the boilers. Each one is controlled by a small enclosure we call the mini SCC. They contain 3 high-speed quadrature encoder-based counter modules as well as 4 outputs, all of which are controlled over Ethernet. You may have seen these mini SCCs during First Stronghold. We use them to count the boulders scored in the towers. For First STEAMWORKS, the mini SCC interfaces with a VisiSight sensor at the output of the boiler.
Hey, cool. Those sensors are in first choice too.
Is he always like this?
Mostly. He gets really giddy when it comes to flashy lights. As I was saying, the mini SCC combined with the VisiSight sensor counts the fuel at the boiler output. That's it for the Alliance station. Let's go check out the airship.
Each airship has its own enclosure, which we tuck up underneath it. Power and Ethernet run to it through the steam pipes.
Each of these enclosures includes an Ethernet switch, some relays, and another armor block module.
We use the airship enclosure combined with an infrared light sensor called RightSight to detect when the gears are spinning, operate the prop motors, and turn the auto lights on and off.
The final items that need some smarts here on the airship are the touchpads. Each one has 3 sensors to detect when the plate has moved the required ½ inch. Some LEDs indicate when the climb is valid. We use the armor block I/O to monitor the state of the switches and to control the lights.
He's definitely going to be okay, right?